In this video here, we're going to take a look at sketching polar curves. Now we can easily sketch polar curves by learning the shapes of some standard curves here. So starting off then, we have r equals a here. So r equals a is a circle with center O, so it's centered at the origin here, and it has a radius of a. For our second standard curve here then, we have theta equals alpha. So this here then is a half line through the origin O, and it makes an angle of alpha with the initial line. And then for our final standard curve here, we have r equals a theta, and this is a spiral starting at the origin. So let's take a look here then at a few different examples for these standard curves. So starting off then with our first example here, let's say we want to sketch r equals 4. So hopefully you recognize straight away that this will be a circle with center O, so it's centered at the origin here, and it will have a radius of 4 units. So in that case then, a sketch would look like the following. So we get a circle here, it's centered at the origin here, O, and each of these lengths then, so this length here is 4 units. Again, we don't actually sketch here, but that length there would be 4 units. Same again here, and then finally, same again here. So a nice straightforward, easy example there to get us started. So now let's move on to the second example here then, and let's say we want to sketch theta equals pi over 4. So what would that look like here? Well, we know that this is a half line that goes through the origin O, and it makes an angle alpha with the initial line. So in that case then, a sketch would look like the following. So as we would expect here then, we get our half line, and this makes an angle of alpha, which in this case is pi over 4 with the initial line here. Okay, so this line here, I haven't written it, but this is the initial line. And I did also forget to label the actual diagram here, or my curve, I should say. So in that case here, this is theta equals pi over 4. Okay, just so I don't forget it there. So there we have it. So that gives us everything that we need then for curves of the form theta equals alpha. And then finally here, let's say that we want to sketch r equals 2 theta here. What would that look like? Well, we know that this is a spiral that starts at the origin O, and in that case then, a sketch would look like the following here. So as we said then, we get this spiral type curve here. So it starts at the origin O, and it just goes round like this here, and it is quite a cool curve, right? So this is for r equals 2 theta, and there isn't really anything else that I can add to this here. So that's a few different examples there for the standard curves that we can sketch. So now let's take a look here at some slightly more complicated examples then for sketching polar curves. So let's take a look then at sketching more complicated polar curves here. Now, as you can see, the title of this page here is Eggs and Dimples, and I do appreciate that that's probably quite a weird title here for this page in the middle of this A-level further maths revision video, but it is relevant. So the reason that this is relevant is because we're now looking at more complicated polar curves here. So for curves of this form then, so r is equal to a times p plus q cos theta, the first thing to be aware of then is these curves are defined for all values of theta if p is greater than or equal to q here. Now these curves fall into two special categories, and you might have guessed it then by the title of this page here. We have a dimple-shaped curve and an egg-shaped curve. Now a dimple-shaped curve occurs when p is between q and 2q, and an egg-shaped curve occurs when p is greater than or equal to 2q. So what do these curves look like here? So for the first sketch here then, we have an example of a dimple-shaped curve. And that looks like the following here then. So we start the initial line, we go around and around here, and we have this little dimple around here, right? It's not particularly pronounced, but you can just about see it. So this here then is an example of a dimple-shaped curve, like so. And in this case here then, p is between q and 2q. Now we also have an example then of an egg-shaped curve. So in this case here then, I'm going to be honest, I can't really say anything too special about this curve. It literally looks like an egg, right? So in that case then, I'll just label this here as an egg-shaped curve. The only thing that we can really say about this then is for this curve to occur, p is greater than or equal to 2q here. Okay, so that's the only thing that we can really say then for this curve here, other than it looks like an egg, right? So, you know, nothing too thorough in terms of the mathematical analysis here. It literally looks like an egg. Okay, So there we have it. That gives everything that we need here then for this page on eggs and dimples. So to finish our introduction here to sketching polar curves, we basically have a closing remark then in regards to sketching polar curves. So for more complicated polar curves here, similar to what we saw on the previous page then, what we need to do is set up a table of values to help us sketch our curve. And we'll see this in more detail then as we work through an example shortly in this video. And then finally here, you may also need to find a polar curve to represent a locus of points on an Argand diagram. And we'll take a look at that in more detail within the next video here. So there we have it. That gives everything that we need here then for sketching polar curves. So let's take a look then at one example here. So let's just take a look then at this example here for sketching polar curves. So for this question here, it asks us to sketch this curve here with this given equation. So to sketch this curve, we need two things here. We need a table of values, and we also need our axes here. Now for the table of values then, along the top row here, this will be for values of theta here. So for values of theta. Now for this question here then, it doesn't actually specify a domain here for theta. So a sensible domain here for theta would be between 0 and 2 pi here. Okay. And then in the bottom row here, these would be the respective values of r in that case. Okay, so we have 0, we then have pi over 2, we then have pi, we then have 3 pi over 2, and then finally here, as we've already noted, 2 pi. Now for the respective values of r here, well, we just obtain those using this given equation here. So nice and straightforward then for the first one, we'd get r equals a times by 1 minus sine of 0. In that case, then we get a. For the next one here, then, when theta equals pi over 2, we get r equals a times by 1 minus sine of pi over 2. In that case, then, we get 0. I'll just keep going here and giving you the respective values of r then. So for when theta equals pi here, we get a. For when theta equals 3 pi over 2, we get 2a. And then finally here, for when theta equals 2 pi, we get a there. Okay. So that gives us our table of values here. So now that we have our table of values here, we can now go on and plot our polar curve here. So don't forget, we start with the initial line here, theta equals 0, right? So when theta equals 0, r is equal to a. So in that case, then this would be, say, here, right? That's a there. Okay. Now for when theta equals pi over 2, r is equal to 0. So the way that this works then is we go counterclockwise here. So we have theta equals 0. We then have theta equals pi over 2. So in that case, then when theta equals pi over 2, r is equal to 0. Okay, so that would be here. So if we think about joining these points up, then let's just join them up as we go. So we go counterclockwise here, like so. Okay. Now for the next one then, this is when theta equals pi, and the value of r here is equal to a. So that would be, say, here, like so. And again, let's just join these up as we go. We get something that looks like this. It doesn't have to be perfect as long as you get the general shape here and the correct values of r here. So that's my third point there. So the next value here then, this is when theta equals 3 pi over 2. We get 2a here. So it would be this line here then. And we get 2a. So I'll be a bit further down, let's say there. So that is for 2a here. So let's just join this up here then as we go. So we get something that looks like that, right? And then finally here, when theta equals 2 pi, we get a again. So in other words, we just arrive back at this point here. So what I need to try and do here then to finish this sketch here, this polar curve, is arrive back at this point. So I am definitely not a good artist. Like I said, it doesn't have to be perfect as long as you get the general shape here. So altogether then we get something that will look like this here. Okay. And there we have it. To be honest, that's pretty good for me. I'm never very good at, sketching curves or anything like that. But that is absolutely fine there. So there we have it. Like you can see, sketching these polar curves, nothing too challenging. For curves like this, we definitely need a table of values like this though. Okay. This doesn't fall under one of our standard curves here. So as we've said then, just draw up a table of values. It makes life a whole lot easier. So there we have it. That gives us the solution here to this question. And that brings the end then of this video here on sketching polar curves.